Welcome to the multivariable calculus section. In this section, we'll be discussing the chain rule. Now, in single various calculus, we learned that when y equals f of x and x equals f of t, or dealing with parametric curves, dy dt is equal to dy dx times dx dt. Now, this makes sense because we can cancel out our dx's and say dy dt. Now that makes sense, but in multivariable calculus we know that z is equal to f of xy and x is equal to g of t while y is equal to h of t. So if we wanted to find the derivative of our z function, we would have to use a chain rule with respect to t. So in order to do the chain rule in multivariable calculus, we need to understand that there is a symbol we must learn. Now this symbol is del. Del indicates the partial derivative of the said function. So in this scenario, we're saying that the del z, or the partial derivative of the function z, with respect to the partial x, which essentially means we're saying f of x, xy. And, and this is being multiplied by the derivative of the x function. So it is going to be whatever the derivative of the x function would be, so x prime essentially. Now we are adding that with the partial derivative of our z component with the y component that is incorporated, multiplied by the derivative of the y function with respect to t. Now, in essence, this makes sense because when we were doing the derivative or the chain rule, in order to compute dy dt, we had to use both components that were involved. Now, in a vector function, z is equal to f of x, y, we have two components that we need to address. Therefore, in the left-hand side, we need to say that we need to clear the dx's, or the derivatives with respect to x, and in our right-hand side, we need to clear the derivatives with respect to y, add them together in order to find our chain rule. Now, that is it for the chain rule section, and if you need additional assistance, there is a bunch on the website. I hope that helps.